Hello everyone. I'm Sam, responsible for frontline service and technical training of equipment maintenance at Lushily Intelligent. This is episode 4 of series 2. The last few episodes covered structural parts, racking, rails, wire rope. Today we finally move into accuracy. The addressing system. You might ask, how does a stacker find every single location so precisely? It's the addressing system. Laser ranging and barcode addressing are the stacker's eyes. If the eyes go blurry, positioning goes wrong. So this episode is about how to maintain and calibrate the addressing system. 4 learning goals today. First, get to know the addressing system, how it actually works, and what laser and barcode each offer. Second, learn daily cleaning and upkeep. It looks simple, but many people get it wrong. Third, master the calibration steps. Fourth, learn to troubleshoot common addressing faults. With these in hand, you'll be able to fix positioning problems yourself. There are 3 mainstream addressing methods. Laser ranging is accurate to 2 to 5 millimeters and fast, but it's sensitive to dust and light. Barcode addressing is more accurate, 0.52 millimeters, but the code tape soils easily. A third option, the incremental encoder on the travel wheel shaft, counts pulses to compute position. Simple, but it accumulates error. Note that the addressing system isn't just one sensor. It's a 3-layer architecture, sensor plus controller plus actuator. And remember one principle: the stacker positions on 3 axes, horizontal by the addressing sensor, vertical by the encoder, and the fork by the telescopic fork limit. Let's look at laser ranging. The principle is simple. The laser head fires a beam at the reflector opposite and back, and the flight time gives the distance. It has 2 key parts: the emitter window and the reflector. The window must stay clean, but mind how you clean it. Always use lens tissue and absolute alcohol, never an ordinary cloth, which scratches the coating. Keep the reflector clean too, and replace it if the reflective film peels off. Also make sure nothing blocks the beam path. Vibration can shift it, so check the alignment at the annual inspection. Now, barcode addressing. It has several parts. A code tape laid along the rail, each segment carrying position information. The reader camera on the stacker reads the code, and the decoder turns it into position data sent to the PLC. Barcode addressing is more accurate than laser, 0.52 millimeters, but it's stricter to maintain. Clean the tape gently with absolute alcohol and a lint-free cloth, wiping lengthwise along the code flow. Never scrub hard. If the tape is locally damaged, cut and replace that segment. If the damage is extensive, replace the whole tape. Clean the camera window monthly, just like the laser window. Cleaning the addressing system looks simple, but the details matter. Use lens tissue and absolute alcohol on the laser and camera windows, and a lint-free cloth on the reflector and tape. A few don'ts to remember. 1. Never wipe optical windows with an ordinary cloth. 2. Don't go straight to alcohol on the code tape. Some inks dissolve in it, so test with water first and only use alcohol if there's no fading. 3. Don't blow the camera with compressed air, which drives dust inside. 4. Never hot plug the sensor connectors. And 1 rule: photograph before cleaning, and verify accuracy after. Now the laser calibration, in 5 steps. Step 1. Clean. Wipe the window and reflector and ensure the beam path is clear. Step 2. Set the datum, drive the stacker to the aisle home position, and log the current laser reading. Step 3. Multi-point measurement. Take 10 to 15 points along the aisle, and record the deviation between laser and actual at each. Step 4. Correct. Enter the deviations into the controller and adjust the offset parameter. Step 5. Recheck. Remeasure from the start and confirm every point is within tolerance. Calibrate every 6 months as a rule, and immediately after changing a sensor. Barcode calibration is similar to laser, but adds a read rate test. Run the stacker slowly from one end of the aisle to the other, and monitor the read success rate. Normally it should exceed 99%, below 95%. Check whether the tape needs cleaning or replacing. Position checking matters too. Stop at several locations and compare addressed against actual. When replacing the tape, note buy the same OEM type. Keep it parallel to the rail when laying and hold segment alignment within 1 mm. After replacing, always verify addressing segment by segment from end to end. There's a simple mantra for troubleshooting. Look, wipe, calibrate, replace, check, record. In other words, look first, then wipe, then calibrate. Only replace if that fails, then check and finally record. The common laser fault is no signal. Usually a dirty window or a blocked reflector. So clean first. For a jumpy reading, check reflector quality and vibration. The most common barcode fault is read failure. Again, clean first. For code jumps, check the tape joints for misalignment. For large position error, recalibrate the parameters first, and only then check whether the travel wheels are slipping. Remember this order, don't jump straight to replacing the sensor. Parameter backup is vital. It's the last line of defense in maintenance. The parameters to backup include the laser's offset and COM settings, the barcode camera and decode parameters, the controller's position table, and the servo drive gains. The best backup method is the OEM software, which captures everything. If that's inconvenient, export via USB from the controller panel. If all else fails, photograph the parameter pages one by one. Use a naming rule, unit number plus date plus version, and keep at least the last 3 versions. Remember, with no backup, swapping a sensor means recommissioning the whole system, possibly losing days of output. After calibrating, you must verify the accuracy. 4 steps. 1. Static. Park at the target location and measure the actual deviation with a steel rule. It should be within target bars. 2. Slow dynamic. Pass at 10% speed and stop. Accuracy within pars millimeters. 3. Fast dynamic. Run at full speed and emergency stop at target. Within pars 5 millimeters. 4. Repeatability. Position at the same location 10 times. The spread should be under 3 millimeters. Choose checkpoints covering both aisle ends and the middle, and low, mid, and high in the vertical. Remember, a calibration without verification isn't finished. This page is the complete maintenance schedule for the addressing system, from daily to annual. Every cycle has defined tasks. Daily, listen for abnormal noise and watch reading stability. Weekly, clean the optical windows and check the tape. Monthly, deep clean and spot check accuracy. Quarterly, full calibration and parameter backup. Semi-annually and annually, full accuracy testing and overhaul. A suggestion: 10. Print this page and post it in the panel cabinet, ticking off each task as it's done. The addressing system is the stacker's eyes. Only regular maintenance keeps them sharp. Here's a real case. At one warehouse, the stacker kept jumping addresses. The position would suddenly leap tens of millimeters. And twice on retrieval the fork went and skewed and a pallet fell. So what was the cause? It took a long search to find that a hydraulic lubrication unit above had been seeping oil, dripping drop by drop onto the code tape. The oil-covered code read blurred to the camera, producing the jumps. The fix wasn't just cleaning the tape off. More importantly, a drip tray under the hydraulic unit, and a shield above the tape. The lesson: fixing the contamination source beats frequent cleaning. Let's recap today's key points. 1. The addressing system is the stacker's eyes. Laser and barcode each have trade-offs. 2. Cleaning is the most important step, but use the right tools and methods. 3. Always verify accuracy. After calibration, that closes the loop. 4. Always back up the parameters, or a sensor swap leaves you blind. 5. Troubleshoot in order: look, wipe, calibrate, replace, check, record. 6. Fixing the contamination source beats frequent cleaning. Take these standards back and check your own equipment against them. That's it for today. We covered the 2 addressing methods, as laser ranging and barcode, the cleaning standards and methods, the detailed calibration steps, plus accuracy verification and troubleshooting. Next episode is the telescopic forks. Once a dressing has found the position, whether the fork reaches in squarely to the location is the fork's job. Thanks everyone, see you next time. Before we wrap up, let me do a quick business promotion. Le Chili Vietnam team is dedicated to providing professional logistics automation equipment maintenance services for Vietnamese enterprises. We have a mature local professional service team. Whether it's routine maintenance or emergency breakdowns, feel free to contact us if needed.